When sports meet science, predicting the outcome of NFL games using Python. My favorite team, the Detroit Lions, have historically had losing seasons and have rarely made the NFL playoffs, leading to very low expectations from fans. In 2023, the Lions achieved a 12-5 record, qualifying for the playoffs for the first time since 2016 and winning their first playoff game since 1991. This success has continued to the 2024 season, as the Lions have started with an 11-1 record, the best in franchise history. Many believe the Lions could win their remaining 5 games and finish the season 16-1, potentially securing the NFL's best regular season record. I was inspired by this idea and decided to create a predictive model to answer the question, what are the odds that the Detroit Lions will be able to finish the 2024 season without losing another game? However, since I needed to use data to represent all of their opponents as well, I decided to create a model that would predict the winners of all remaining NFL games, as well as the final record for every NFL team. Before I could create the predictive model, I needed to create a data set containing key information and statistics of NFL teams. Once I had created the data set, I imported it using pandas. I decided to use the extension's random forest classifier, which will be used to predict the outcome of each game using a slight inconsistent degree of randomness, and train test split, which will be used to create training data for the model from scikit-learn. I then began working on a function that would take in the name of an NFL team and the dataset used, in this case the NFL dataset, as arguments. In the function, I then created a separate dataset that would include the stats of the opposing team based on what team is selected as the argument. I then merged this dataset into the original NFL dataset, applying the opponent's stats to each team's Week 14 opponent. This is not necessary for the other weeks, as the model is designed to dynamically update win-loss statistics. I created a variable in the function for the statistics of the specified team, as well as 2 variables that stored the wins and losses of the specified team. After that, I created a comprehensive dataset using an empty list that would contain the specified team's future games, which would then be passed into the machine learning model to predict outcomes. Without this step, the predictive model would lack the necessary statistics to make accurate predictions. In the next section of the data, I created a list of columns, the data from which will be used as the training data for the predictive model. After that, I used the columns as the data for the feature matrix and used the specified team's wins and losses for the target vector. I then split the data into a training set and a testing set with train test split, implemented the random forest classifier used to predict outcomes, and then trained the model. After training the model, I then created an empty list that would eventually be used to store the game outcomes of a specified team, as well as a dictionary that would be used to dynamically track the team's wins and losses. One of the most important steps in creating my predictive model was to write a for loop to iterate through each matchup and determine a winner. First, I extracted the statistics for the specified team and their opponent into 2 separate variables. I used the trained model to predict the probabilities of both teams winning based on their statistics. Using an if-else statement, I determined the winner by assigning 1 for a win and 0 for a loss based on the probabilities. Still within the loop, I used if statements to update the specified teams and the opponent's records in the team records dictionary, accounting for teams not already included. Finally, I appended the game results to the empty game outcomes list. The final step in completing my function was to create a variable that would include the specified team's final predicted record, as well as a variable including the team's name, the predicted final record, and the outcomes of their games over the final 5 weeks, which would be returned when the function was run. Using the function with the Lions as an example, printed a line of text including their record, 16-1, and all of the results of their games. As we can see displayed in this table that was made using Google Sheets, the Lions ended up winning their remaining 5 games, one of only 2 teams to do so, the other being the Philadelphia Eagles. One thing to note is that the NFL is divided into 2 conferences of 16 teams, while those conferences are themselves divided into 4 divisions of 4 teams. The winners of each division are seeded 1 through 4 based on their record. This is why a 9-8 team such as the Seahawks is seeded higher than teams with better records such as the Vikings and Packers. An interesting pattern that I noticed is that the model seems to prefer certain final records, as there ended up being 5, 6, and 11 teams, as well as 5, 3, and 14 teams, while there are no 4, 5, or 8 win teams. This pattern is further displayed in the pie chart, with a total of 59.4% of teams won either 3 or 0 games. The model also seemed to favor NFC teams over AFC teams. My research question was, what are the odds that the Detroit Lions will be able to finish the 2024 season without losing another game? According to my model, the odds are 100%, but this doesn't guarantee they'll win since factors like injuries, weather, and player performances aren't included. The model is based solely on win-loss records and points scored for and against, which simplifies the complexity of real-life NFL games. I encountered obstacles such as game results being independent of each other, unrealistic outcomes such as every team winning or losing all of their games, and bias from Week 14 results affecting predictions. Ultimately, I learned that predictive models are inherently flawed due to the human element in sports, but that they can still provide valuable insights.